All right, so let's see this particular problem now, K-anagram problem, right? So in this particular problem, we are given two strings S1 and S2, and we need to find out if these two strings are basically K-anagrams of each other or not, right? And how do we define a K-anagram? Basically, we call these two strings as K-anagrams if, first of all, they have equal length, right? They have the same length. And secondly, we can change at most K characters in either of these two strings, S1 and S2, to actually make them anagrams of each other, right? And just to define anagrams for those who don't know about it, two strings are called anagrams if they have all the characters in common, including the duplicates, right? So all the characters in S1, including the duplicates, should be present in S2 as well, right? If that is the case, then S1 and S2 are called as the anagrams of each other, right? And that's what we need to find out, that if these two strings are actually K anagrams of each other, that if they can be made anagrams of each other by replacing at most K characters in either of these two strings, right? So that's the question entirely, right? What we need to do. Now, if you see this particular example over here, anagram is the string 1 and grammar is string 2, right? And the value of K is equal to 3, right? Now, if you see these two strings, you will be able to make these two strings anagrams of each other by actually making less than three replacements in either of these two strings, right? We will be backtracing that, but then you can check that for yourself. You will be able to make them anagrams of each other by actually making at most K replacements, where K is equal to 3 in this particular example, right? So that's the entire question. That's what we have to find out. And now maybe you can just pause this video and try to think of a solution for this. And once you are done, you can just come back and check the solution here. Okay, so now to solve this particular question, let's take this particular example itself, right? In this particular example, we are given, as we know, two strings, anagram and grammar, right? And the value of K is 3, and that's why we are calling it as 3 anagrams, right? So now, first of all, what we will do is, we will first of all check the length of both of these strings, right? And since the length of both of these strings, if you see over here, is 7, right? That means they are equal. So we are good, right? And then we will proceed to the next step, right? Now in the next step, what we will do is, we will create a frequency array of, string 1, right? So that's what we are saying over here. We will create a frequency array and we will be storing the count of each character in this particular string 1 in this frequency array, right? So this is how it will look like, right? And now what we will do is, we will just iterate over string 2 now, and we will start comparing each of its character one by one with the characters of S1 which are present in the frequency map over here, right? And we will try to figure out with each character that we are looping over in this particular second string whether we have encountered a mismatch or not, right? And we will say that a given character is a mismatch if that particular character does not exist in this particular string or in this particular frequency map of the first string, or if the number of times it occurs in string 2 is actually greater than the count of that particular character in this frequency map of the first string, right? If either of these two conditions satisfy, then we will be calling that particular character as a mismatch, and we will be actually maintaining a count for the mismatch, right? A count variable, and we will be incrementing this particular variable whenever we detect a mismatch which follows the mentioned condition, right? And if at any point in time the value of this mismatch count becomes greater than K, right, which is 3 over here in this case, we can actually return false, that these two strings cannot be K anagrams of each other because there are more than K mismatches in these two strings, right? So that's what we will be doing. Now if we backtrace this particular solution over this example, so we will just start looping over this string 2 now, right? So in the first iteration, I will get G as the character, and I will just make an entry of it over here in hash 2, right? And also I will see whether it is present in hash 1 or not. It is present, and also the count is actually lesser than or equal to the count of G in hash 1, right? Hence, we are okay with this and there is no mismatch, and so the counter will still be 0, right? Now next we get R, right? Now it is found in hash 1 also over here, right? And hence there is no mismatch over here because even the count of R that we got in hash 2 currently is actually lesser than equal to its count in hash 1, right? So we are good even here, right? Now the next character over here is A, if you see, right? So we got A. Now again A is equal to 1 over here in the hash map 2, and over here in hash 1, which is the frequency map of the first string, we are getting A count as 3, right? So again the count over here is less than or equal to, the count over here in hash 1, and hence this is also not a mismatch. So our count still stays 0, right? Now the next character is M, right? And it is also found in hash 1. So again, there is no problem over here, right? Now, once we go to the next character, again we get an M, and then this particular M, now we have got the second time, right? Whereas, so the count over here becomes 2, whereas the count over here in hash 1 is actually only 1. So now my count in hash 2, that is in string 2, became greater than, the count of M in hash 1, which is string 1's frequency map, right? So now this will be considered as a mismatch, and so I will just increment my count variable's value by 1, and now the count value will be 1. So I have encountered one mismatch so far, and now I will just move to the next character, right? So the next character is A again, and now A appears again, and so the count of A now becomes 2 over here, but the count of A over here is 3. So again, this is also not a mismatch, right? And now I go to the next character, and this is R again, right? So R, the count over here is 1, whereas now the count of R over here in string 2 becomes 2. So now this 2 is actually greater than 1 over here. Hence, I will say that this is another mismatch that I have found. And now R was my last character, right? Now I have hit the end of the loop. So I will come out of this loop now. And now if you see, the value of my count is equal to 2, which is actually lesser than the value of the K over here, that is 3. And hence, I can actually make these two strings as anagrams of each other by doing at most K replacements, and hence these can be called as K-anagrams of each other, right? And hence, finally, I will just do this particular comparison, and then I will just return true, because we have found out that the number of mismatches are actually lesser than or equal to the K integer given in this particular question, right? So that's the entire solution that we are going to follow using the frequency maps, right? And now talking about the time and the space complexity. See, time complexity, we are just iterating over both of these strings one by one, right? So we will be having two for loops, right, in sequence. So we will be having linear time complexity only, right? It will be order of n plus order of n, which will be essentially just order of n itself, right? So time complexity will be order of n, and space complexity, we are not using any extra space over here, which is actually dependent on the size of the input. So we are indeed making these frequency arrays, but these frequency arrays will just be of constant size, which will be equal to the number of characters which are present in the English language, right? It won't be more than that. So it's not dynamic, it won't be dependent on the size of the input. It will be always constant, and hence the space complexity will be order of 1 over here, right? So this is the entire solution. I hope you understood it well, and now let's see the code of it. All right, so now let's code the solution that we just discussed. So maybe first of all, let me just declare a function over here called maybe K-Anagrams, like this. And this will accept two strings, s1 and s2, right? And also a variable k, right? And now what we need to do is, first of all, we can just capture the length of each of these strings in variables s1 and s2 respectively, like this, right? And let me just do the same thing for s2 as well. Let me capture the length of s2 in a variable n2, right? Like this. And now what we need to do is, first of all, we can just check if n1 is not equal to n2, right? In that case, we can straight away just return false, right? Because the first condition is that these two strings should be of equal length, right? And if their length are not equal, they cannot be made as anagrams of each other, right? So that's why we will just return false if n1 is not equal to n2. And now what we can do is, we can just first of all declare two hash maps over here, two empty hash maps corresponding to string 1 and string 2, like this, right? And now what we can do is, as we had discussed, we will just iterate over the first string now, and we will keep populating this hash one with each of the characters as the key, and the count of the number of times that we have seen that particular character in string 1 as the value of that particular key, right? So that's what we will do. Now I will just iterate over n2 in range n2, right? And now what we will do is we will just check if the current character is not in hash 1, right? Like this. If it is not in hash 1, we will just create an entry like this, right? And update it to 1, which will be the count, because I have just seen once this particular character up till now. And if it is already present in hash 1, the current character, in that case, we will just update the value of this particular character by 1, like this, right? That's what we will keep doing, and at the end of this for loop, we will have all the characters populated in this particular hash 1 with their respective count, right? So that's what we are doing over here. Now what we need to do is, now we have to iterate over S2, right? And we have to keep checking if for every character that we are getting in S2, do we have that particular character maintained in hash 1 or not? If not, we will just increment the count variable value. And of course, I also need to declare the count variable over here, right? I can initialize it to 0, right? And now I will just iterate over S2, and I will keep checking whether each of the character is present already in hash 1 or not. And also I will check if the count that I'm getting in string 2, whether that particular count is basically lesser than or equal to the count that I have for that particular character in hash 2. If it is greater, in that case also I will increment the count variable, right? So all these things we have already discussed. So now let me just iterate over, and also I'm sorry, this should be n1, this should not be n2, right? So now I will iterate over n2, right? And now I will just see the same thing, right? I will do the same thing over here now. I will just copy this particular entire code block from here to here, right? And instead of S1, it will be S2 now. Instead of hash 1, it will be hash 2 now, right? And same thing over here. I think this should have been hash 1, yeah. And this will be hash 2, and this also will be hash 2, and this will be S2, and this will be S2, right? And this will be S1 and S1, right? I think I missed writing 1, in the previous for loop, but nevertheless, we have corrected that now. And now what we will do is, so this is the common part, right? But now after doing this updation, what we will also do is, now we will check if my S2 of I, that is the current character of string 2, whether that is present in, or if it is not present in hash 1, right? In that case, or in case, the count of this particular character in string 2 is basically not this, but this, is actually greater than the count of this particular character in hash 1, which is in string 1, basically, right? Like this. If any of these conditions get true, either of these conditions, if either my current character of S2 is not at all present in hash 1, or if the count of the current character in hash 2 is actually greater than the count of the current character of S2 in hash 1, in either of these cases, I will just increment my count variable by 1, right? And now after doing this updation to count, now I will also check if my new value of the count is actually greater than k or not, right? Now if it is greater than k, I can say that these cannot be K-Anagrams, because they don't have at most k different elements, they have more than k different elements, and I can just break out of this loop and return false, right? That they are not K-Anagrams, right? But then if this condition doesn't get met, right, I will just continue with the for loop, and once I'm done iterating over the entire string S2, if I'm never able to break, if I'm never able to hit this particular condition, it would mean that these two strings actually have less than or equal to k different elements only, right? They don't have more than k different elements, and in that case they can be called as K-Anagrams of each other, right? And hence I will just return false, I'm sorry, true over here, right? So this is the solution entirely. I hope you understood it well, right? Now maybe we can just quickly test this particular solution on the same test case that we had earlier. So I think the strings could be anything basically. Let me just declare S1 as maybe GORK, right? And S2 can be maybe FODR. I think these were the two strings. If not, it doesn't matter, right? And K can be 2, right? And now I can just print the output of this function when called over these two strings and this value of k, right? Like this. Now if I run this, my output should be basically true because I just have two different characters over here, right? So if I run this now, let's see what I get. Okay, let me just run it again. Yeah, so I get a true over here. That means they are actually K-anagrams of each other. And the moment I actually, uh, change any other character also, if I make the different characters as 3 over here, for example, I change this to R to O, right? So now my value should be false, right? My output should be false. So let's see. So I have done a typo somewhere. Yeah. So this should be actually S2, right? Not 2. So now if I run this, my value is, my output is false, right? So it is giving us the correct output. So this is the entire solution. I hope you understood it well. Again, the time complexity over here will be order of n and space complexity will be order of 1, right?